Alright, lesson 3, number 3. And we have to pick all the ones that match this diagram. Okay? We've got 1, 2, 3, 4, 5, 6 x's. So I'm either looking for 6x or 6 individual x's written out long expanded form. We talked about that. Okay? Those are the same thing. So if we see both of those over here, we know it's a possibility. And we know that we have a total of 35. So we're looking for 35 kind of, being part of the equation, obviously. Alright, so a total of 35 is equal to 1x plus 1, 2, 3, 4, 5, 6 x's. That's good. I mean, that's exactly what's happening. I mean, it doesn't get more exact than that. And then from A to B, they're just, talking about this. So instead of writing out all those 6 x's, we can shorten it with 6 times x, because that's repeated addition. All right? C has thrown the 35 on the right. I mean, you still have 8 plus 6 involved, but notice, if you're careful, that the 8 is with the x's. We do not have 8 x's. We have 6 x's. We do not have an individual 6. We have an individual 8. So don't pick that one. This one goes back to what we do have, which is we do have 6 x's and we do have a singular 8, and it's okay to switch their sides. Property of equality. Fine. E, we can't just throw x's on the 35 and the 8 because they are not unknown quantities. Those are known quantities, so we can't do that. And then lastly, F is a controversial one, but if you took this 8 away from the 35 total, what would you be left with? You would be left with 6 x's. So that makes sense to me as being a correct equation to match the diagram. They're kind of on their way to solving it, is what they're doing. And so that's number 3. Let's go on down to number 4. Complete the magic squares so that the sum of each row, each column, and each diagonal are all equal. Well, to do that, you need to find out one row or diagonal that you know and make all the other ones happen. So 7 plus 2, we need everything to add up to equal 9. Alright? So everything's got to add up to equal 9. So I'm going to go here next because I'm only missing 1. 7 plus 3 is 10. I need to go down 1, so that means I have to use that to make this equal 9. The next one that I could do that has 2 already finished is the diagonal. And to make 0 plus 3 equal 9, this would have to be 6. Now I can go upwards. 2 and 6 make 8. So therefore I need 1 more to make 9. And now we can work the other way around. So 6 minus 1 is 5. That would have to be 4 to make 9. And for this to be vertical and make 9, this would have to be a 5. And you can check some of the other ones. It does make 9 as you go through. So that's the process. Pick one, find out what it is first, what it needs to be, and then make everything else match. Okay? So 5 plus 3 plus 1, the diagonal has to be 9 again. So 9 is our sum. And 3 plus negative 2 is 1, so that makes this 8. 1 plus 8 is 9, so this needs to be nothing, which makes this needing to be 4 because 5 plus 4 and 0 is 9 as a sum. 3 plus 4 is 7, which makes this 2. And 1 plus 2 is 3, which means this needs to be 6. And it all works out. 4 plus 2 is 6, so this magic square has a sum of 6 as its total. And we know we can fill this one in up here. So you just kind of have to work around the square as you go. 4 plus negative 1 is 3, so that means this would have to be 6 in order for, let me go back, sorry. That's wrong. Our sums are 6 on this one, so if that's 3, this needs to be 3. Diagonal next. 3 plus 2 plus 1 would be 6. We can do this one next. This one must be 6 for that to work. 2 plus 6 is 8, so this would need to be negative 2 to work. And 3 plus negative 2 is 1, which means this would have to be 5. And there we go. There's number 4.